Hi everyone, how are you today? My name is Junaid Hasan and today I'm going to attempt my midterm for data mining class and these are my questions over here. I got like 4 hours to solve that one and my dataset was UCI credit card dataset and these are my questions which I will be showing you right now and all the things which I have run so far. Okay, so for question number one, we have to upload the data, then we have to create a subset showing only data for people under 35. So this is my Google Colab notebook. So first I imported all the libraries which were needed for this one, all the packages, and after that I have installed, uploaded my data, UCI credit card, CSV. This is my data, dataset.head to see, like we can see my dataset is uploaded now. And then the question number one, subset for people under 35. So we can see I have created a subset for people under 35. Data set age, and then removing the ID column, we can see like here's the ID column over here before, and in the second one, after looking up the data, I'll delete the ID, and after looking at the data we can see there's no ID column over here. So we're done with the question number one. Then we're gonna move towards for multiple regression. Question number two, for people under 25, under 35, build a correlation table to determine the best predictor for a multiple regression. All right, so the correlation table was made for, I have set the age before here 35, subset people for under 35, and the correlation made table was made for age under 35, and the correlation table provides the correlation between all the variables of our data set. From the correlation we can easily determine which values are highly correlated to each other and which variables would be the best predictors for other certain variables. So as you can see here, so the best predictors was age and marriage, and so we will be using the age and marriage variables here, it's in the question number 3. The best predictable we have to choose for question number 2, then build a multiplication model based on the best two predictor from question number 2.1. So the age and marriage was the best predictors from our table, and then here we can see it's a 0.2 random test was made. Then building a regression model with two best predictors, here it is, and code for that one. And then question number 3, predicting education and computing its accuracy. We have to do the predict the model use this model to predict the education of someone under 35. All right, so here it is, the print of the accuracy for training data. Accuracy was 4.76 Wolf score. And then you can see here it's the second one for 4.79, and communicated using crosswalk. Then we can see the question number to evaluate the quality of your model. All right, then that's the quality accuracy, you can see 4.79. Then just to see the question number 3 is a build a logistic regression, build a training 60 with a 67% and test 33% set of your data. So which you can see splitting the original data set into 67% training and 33% training sets. Testing set trained data 0.67 and getting rows for age 35, then getting only the limit ball education as is 3.2. Let's see again based on limit ball and education. Let's see here limit ball education. Then defining the model for logistic regression using the lr.fit function. In the model to predict default and under 35, evaluate the model with the confusion matrix is 3.3 and 3.4. All right, then you can see the 3.3 payment default dot payment dot next month predictable is equal to model X. You can see the score test as 80.49. Then we have plot the confusion matrix here. So the confusion matrix tells us that the model have correctly predicted 4,000 samples, uh, which are zeros predicted as zeros in the set that, and have wrongly predicted 1,000 samples, which are ones predicted as zeros. So here we're gonna go towards our question number 4 now. So I've selected the this and beans here, and it's getting stuck. Hold on. Oh, good. Then we are in the tab. So for question number 4, k nearest neighbor or Nabins. So 4.1, build a new training set for the first 25,000 rows as I have created here, and the last 5,000 rows as testing set. Here are the code for that one, the head and tail. For the start rows, we use head, and for end rows, we use tail. The selecting rows where age is greater than less than 35. Here we have the user classifier to predict under 35% marriage status. Here it is. Class fitting training data. NB is equal to Gaussian NB, external and Gaussian period the one here. Then predicting marriage status using our model and predicting the test score here. The test score was 73.33, and accuracy is then I have the printed the classification report here, and accuracy we can see it's 0.73 is multiplied by 100, so it's a 73.33 test accuracy report here. So the classification report also tells us the class-wise accuracy of our model. It also tells us how many samples support the predictions of our model, which means they were correctly predicted. And so for the one here, explain what your insights your analysis is going to produce for a manager or government official who has to make the decision based on our analysis. So this is the answer. So my analysis highlights the relationship between different variables in our data sets. It also explains how some variables can be used to predict other. A manager can easily understand the general trend in a population using my analysis. He can look at the repayment history and determine the default payment by only looking at the highly correlated variables. Furthermore, he can easily figure out different trends based on age, group, marital status, and education as well. And we can see like if a manager wants to see like different age wise and all if a manager wants to classify the reports according to age, marriage, anything, so manager can predict that one. Also manager can see the accuracy rate of my data. You can see here. So I think I'm done with the midterm here. Now I have explained all my questions, all my answers. All right, thank you so much everyone. All right, let me now. Okay, so yes, here's the logistic, all the data sets here, multiple regression, pre-processing, and multiple regressions done. This is my table. You can see here logistic regression. Question number 3, question number 4, naive beans, accuracy, quality of report, and all. All right, so thank you so much everyone. Hope you will like this video if you see it. Thank you.